So good morning to all of you TyBscPhysics student. So today we want to see in the subject nuclear physics. We want to continue our second chapter is the radioactivity. And the summary of the last lecture we have to already see that here what is meant by the radioactivity. So that radioactivity means that the spontaneous emission of the energetic radiation from the substance, this radiation which is known as the radioactivity. And after that we have to see that radioactive substance which are emitted the radiation, so that radiation in terms of alpha rays, beta rays and gamma rays, and that showing the property of the alpha particle which have the positive charge on the alpha particle, beta particle have negative charge, and gamma particle are electromagnetic rays which are electrically neutral. And that understanding of this concept already seen in the last lecture, that see the demonstrated the small experiment that radioactive substance which is placed in the external magnetic field and electric field, that show the deflection of the particles or deflection of the rays, that showing the charge and property of the material. So in this lecture we want to see the properties of the alpha particle, beta particle and gamma particle. Now first of all we want to see the properties of the alpha particle. So first property of that alpha particle is the charge is positive and like a helium nucleus consisting of 2 protons and 2 neutrons and has 2 units of the positive charge. So this is the first property of the alpha particle. So that an alpha particle is, so first property, so that is the an alpha particle is a helium nucleus consisting of a helium nucleus is consisting of 2 protons and 2 neutrons, 2 protons and 2 neutrons, and 2 neutrons has 2 units positive charge, has 2 units positive charge, 2 units positive charge. So this is the first property of the alpha particle. Now next property which is related to the velocity, so that is how much speed alpha particle travel or what is the range of the velocity. So that these rays, that is alpha rays, travel with high velocity. So that is the second property, that is these rays travels with high velocity, that range from this velocity, that high velocity ranging from 1.4 into 10 to the power 7 to 1 into 10 to the power 7. So that is 1.4 into 10 to the power 7 to 1.7 into 10 to the power 7 meter per second. So that the velocity is high ranging velocity and they move along a straight line, and they move along straight line, Okay, this is second number property. Now third number property which is considered as it is deflected or not deflected, or we have to know that experiment that idea that alpha particle which is deflected by electric field and magnetic field, so that they are deflected by electric and magnetic field. They are deflected by electric and magnetic field so that is the one of the property, and which shows that they are charged particle. So that's why, which shows that they are charged particle. They are charged particle. So that alpha rays or alpha particle which are shows electric and magnetic property, and depends on this property that I have to conclude that alpha particle are the charged particle. Next property, which is they produce the fluorescence when fall on the surface like barium platinocyanide or zinc sulfate, and that fluorescence can be observed through a low power microscope. They produce the fluorescence. That next main property. So that is the property number 4th. They produce a fluorescence. They produce a fluorescence, and when fall on the surface like fall on the surface like barium platinocyanide and or zinc sulfate so that have the alpha particle or alpha rays have produced the fluorescence, and the fluorescence can be observed through the fluorescence can be observed through a low power microscope. This is the 4th one property. Now next property of this, they are scattered by nuclei of heavy atoms. They are scattered by nuclei of heavy atoms. So that is the alpha particle. If the charge on the nucleus is more, so that this alpha particle which is incident on this heavy nuclei, so this alpha particle is scattered. And last property of this, that they can ionize the gas. They can ionize the gas. They can ionize the gas. Okay, so that is mean by the ionization power is very large as compared to beta rays and gamma rays. So that is their ionization power. Their ionization power is very large. Is very large as compared to beta rays and gamma rays or beta particle or gamma particle. So these are the basic property of the alpha rays. So that is first property, which is considered as that alpha particle is a helium nucleus that consisting of two protons and two neutrons, and that's why that has the 2 units positive charge. Second property, that these rays which is travel with high velocity, and that range of velocity which is 1.4 into 10 to the power 7 to 1.7 into 10 to the power 7 meter per second. So that is very high ranging velocity. Next one, which is considered as they deflected by the electric field and magnetic field. That's why we have to see that, or we have to say that alpha particle is the charged particle. Next property, which is considered as the alpha particle which is produce the fluorescence that can falls on the material like the barium platinum or zinc sulfate, and that the fluorescence can be observed through the low power microscope. Next property, which is considered that alpha particle which is scattered through the scattered by a nuclei of heavy atoms. And last one, the ionization power of the alpha particle is very large as compared to beta particle and the gamma particle. Now next point, we want to say that the properties of the beta rays. So as we have to see that the properties of alpha rays, the alpha particle which is the positive charge. Similarly, that beta particle have negative charge. That symbol like beta is this. So that is the properties of the beta rays. So that first property, the beta possesses negative charge and mass equal to that of an electron. So the beta possesses, first property, beta possesses a negative charge beta possesses a negative charge and mass equal to that of an electron, and mass equal to that an electron. So that is one of the property. Now second property, which is considered as the beta rays travel with very high velocity. Beta rays travel with very high velocity. So that range of the velocity which is nearly equal to 1/10 of the velocity of light. So that beta rays is travel with very high velocity and nearly equal to that 1/10 velocity of the light. velocity of the light. So that is the second property of the beta particle. Now next property of beta particle, which is considered as their ionization power is small as compared to alpha particle and hence have long range. So third property, the ionization power is small as compared to alpha particle so that's why, and hence have long range, so that next property of this beta particle, which is considered as these rays affect photographic plates. These rays affects photographic plates. So this is the fourth one property. Next property, that they produce fluorescence in barium platinocyanide. They produce fluorescence in barium platinocyanide. Next property, which is considered as their penetration power is more than alpha rays. Their penetration power is more their penetration power is more than alpha rays. Their penetration power is more than the alpha rays and can penetrate through thin metal foils and can penetrate through thin metal foil. So these are the properties of the beta particle. So that beta particle which possesses a negative charge and mass which is equal to that of the electron, that next beta rays have traveled with very high velocity that nearly equal to the 1/10 of the velocity of light. Next, their ionization power is small as compared to alpha particle, and this affect the photographic plate, and penetration power which is very large as compared to the alpha particle. Now next property we want to see the property of the gamma particle or the gamma rays. So next point we want to see that the property of the gamma rays. So that the first property of the gamma ray, which is considered as gamma rays are the electromagnetic wave, and which is in nature having very small wavelength, and that wavelength ranges from 0.005 angstrom unit to 0.5 angstrom unit. So that is the first property. Next one, they are electrically neutral. they produce the fluorescence, and these rays which is not deflected by electric and magnetic field, and penetration power is very high as compared to the beta rays, and ionization power is very small. So that this property see by one. So that properties of the gamma rays. The gamma rays are electromagnetic waves. First property, the gamma rays. The gamma rays are electromagnetic waves. The gamma rays are electromagnetic waves in nature having very small wavelength. In nature having very small wavelength. Having very small wavelength ranges from 0.005 angstrom unit to 0.5 angstrom unit to 0.5 angstrom unit. So this is the first property of the gamma rays. Second property which is considered as they are electrically neutral. They are electrically neutral and travel with velocity and travel with velocity equal to the velocity of light, equal to the velocity of the light. Next property which is depends upon or consider they produce fluorescence and affect the photographic plate. They produce fluorescence and affect the photographic plate. Affect the photographic plate. Next property which is considered as these rays are not deflected by electric and magnetic field. So that the property number 4, these rays are not deflected by electric and magnetic field. So that already see in the last lecture, that experimental study. Next one is their penetration power is very high. Their penetration power is very high, as compared to beta rays. and next one is that points which is depends on the ionization power, and their ionization power is very small. Their ionization power is very small. Okay, so these are the properties of the gamma rays. So that the gamma rays which are electromagnetic waves or which is having in nature ranges from the 0.005 angstrom unit to 0.5 angstrom unit. Next, which is they can electrically neutral and travel with the velocity, that velocity which is equal to the velocity of light. Next, which is they produce the fluorescence and affect the photographic plate. Next one, which is considered as their ionization power, or the or first property that they gamma rays which is not deflected from electric and magnetic field. Ionization power is very small and penetration power is very large or very high as compared to the beta rays or beta particle. So these are the properties of the alpha rays, beta rays and gamma rays. Now next lecture we want to see the law of the radioactivity, what is mean by the disintegration and what is mean by the decay, and what is the mathematical expression of the law of the radioactivity. So thanking of you.